Hello and welcome to Career Tech Explorer, a channel where we discuss a whole lot of things that will benefit you and make your life better. We are discussing R in this series of videos. Please stay back and enjoy. Today I want to discuss how you can use R programming language to analyze data, especially when it comes down to the use of analysis of variance. So analysis of variance. So let me start by, I'm sure you know, if you do not know, if you want to open a new script where you can do your job or do your work, you click on this little plus sign here, and then it gives you room to select R script. When you do that, it will bring a fresh page where you can do your work for you. So the next thing that we need to do, let's just say we name this script analysis of variance. That is Anova for short. Okay, so just so that when you open the script you can recognize what it is used for. The next and the first important thing for you to do is to set working directory. Okay, working directory. To do that, you just type the code setwd. Setwd gives you that. And one of the best things you need to do is to get the file address of the folder that you want to use. Right click on it and go to properties, and you can get it like this. Highlight it and then go over to your R script space, paste it inside of that space. Meanwhile, it must be inserted in inverted commas. So you paste it /R_T, that is tutorials. Let's be sure of the good tutorial. So, and then all of these strokes, we call them strokes in my country, or you can call them slashes. You have to make them forward slashes, not backward slashes. So when you run this first code down, as you can see here, since the code we ran is in blue, the color is blue, that means the code that we ran is working just fine. Then the next thing we will need to do is to import our data from the working directory into R. Maybe let me use R, the capital letter R. Now I need to tell you that I have got 3 data sets for students' course in a test that is called over 30, where 3 different methodologies were used. Students' course for this course, and the strategy used is method 1. Method 1 can be anything, and we have method 2 as well, and indeed we have method 3 also. So the files are named method 1, method 2, method 3. These are they. Okay, so go over to your R and read them into R. So we will assign name method 1. Assign method 1. Method 1 is, then you say read .csv. Now these files are in CSV. Insert them in inverted commas and type method _1. Now if we run this code and we get it blue, it shows that the file has been imported correctly. Now, the reason why I decided to do this, it was deliberate. We must include the file extension c.csv for the file to properly be imported. As you can see, method 1, the file has been properly imported. So we go for method 2, assign variable, and we say read.csv, insert in inverted commas, and we say method underscore 2.csv. You run that line, the data set has been read into R. Bring in a third, method 3, assign variable, and say read.csv, inverted commas, method underscore 3.csv. When you run this code as well, you have successfully read your data into this space. Now, one of the things that I advise is that in as much as we're dealing with the data collected from 3 different experimental situations, maybe from 3 different schools, we will need to merge the data into one data set. So we now say merge the data into one file, let's say called method merge. Okay, so now we call it method underscore merge, assign vector. Now what we are going to do is to use the function rbind. Rbind is what helps you to merge your data. Okay, so we will merge the first, method underscore 1, comma, method underscore 2, insert a comma, method underscore 3, and run your code. So when you do that, you have successfully merged these 3 data into one set called method merge. You can view your data. Let's see. View the data. To view the data, you just type view. View starts with a uppercase V, open bracket, and you type method underscore merge. Okay, run that code by clicking run. We can see that our data has been effectively collapsed together, and we're having over 800 data points, or should I say 800 entries. Okay, one thing I almost forgot is that we need to save our scripts. Save your script so that when you go out of this space, you can effectively come back. So let's call it Anova tutorial. Okay, Anova tutorial. So when you save, it becomes an R file. You can see it here, Anova tutorial.r. Nice. So one of the things next we need to do is to clean the data. Clean the data. So to clean our data, we are going to rename and say method merge cleaned, assign vector and say na.meet, na.meet, meaning that it should remove all missing values. So, and then we type method underscore merge. So we're cleaning our data. You run your data by clicking on R, run. Your data is now cleaned. This is very beautiful. You can perform a little bit of summarization. Let's build, let's say create the frequency table for the cleaned data. So to do that, you can say table1, table underscore 1, signing vector, and then you say table, right, open bracket, and then you say calling the data sets. We're doing that for clean data, and then enter $. We will do a frequency run for student score. So do a frequency tabulation. That has been done. Then you can view that, view the table, and to do that is view table underscore 1. So when you check it out, you see that for the variable 12 and so on and so forth, okay, we have 21, 19 for instance, we have 43, 21, 44, and so on and so forth. Okay, so that is your data viewed. Next thing now, we may also want to say let's also create table 2. Let's also create table 2. Okay, say table and method merge cleaned. And then strategy. We run that. We also ask the program to view table underscore 2. We run that. We see that we have 300 method 1s, 285 method 2, and 229 method 1. Beautiful. And so far so good. We do not have any missing values because that would have also showed up in the table. So at this point we will now go ahead and do our Anova. So let's just say Anova. Okay, so to perform Anova analysis, the first thing we need to do is to fit the Anova model. So we're just going to first change this to Anova analysis. Okay, so the first thing we're going to do is fit Anova model. To do that, simply just say Anova underscore model assign, and you say AOV. Before we do this, we need to call in the libraries. Otherwise, call in deploy R as well as the library CAR. These two must first be called and brought up to speed so that the analysis can be done. So AOB open bracket the data, the independent variable and the dependent variable. In this case, independent variable is student score. Student score, going to student score, and we use tilde, meaning that it depends on strategy, comma, data equal to method merge cleaned. Method merge cleaned. We run this. That has run properly. The next thing is to tabulate our results. So you say tabulate the results. To do that, we just say Anova table sign vector, and say Anova, okay, Anova model, Anova model, and we run this, which is working properly. Then we can now view our table. View the table. View the table, of course, is VIEW, open brackets, Anova underscore table. And we run it. We have our Anova table, as you can see. So, ladies and gentlemen, if you're enjoying what you have seen so far, do well to support my channel by clicking the like button, subscribing to this video, sharing it with your friends. Thank you very much. I'll see you on the next one.